Here's a quick tutorial on Hess's law problem. I know we didn't get really a whole lot of time to talk about this in class on Tuesday, so hopefully this helps. So here's a typical problem. So you got to figure out the delta H, and this is usually for a reaction, for an overall reaction given below, and then you got some step information or some other reactions that you can use to build this overall. So the overall we're going to look at is this one right here, 2 moles of NO2, nitrogen dioxide, plus half a mole of O2. Remember, that's kind of that weird fraction moles. And then that's producing N2O5. We want to know the delta H of that process. Here are our steps. So it's kind of like a puzzle. We got to rearrange these steps to get this. We're going to cancel out some stuff to figure this out, but we want the correct moles that they have up here in the overall. So we got to build that out of here, and that's going to affect the delta H's for the individual steps. So let's start building, and we'll see how it affects those. Here we go. I know that in my overall, and I'll just kind of do a dash here at the bottom, and that's how I like to do it. So I know what I'm trying to get. I'm trying to get 2 moles of NO2 plus half a mole of O2 as a reactant, and N2O5 as my product, 1 mole of that. I'll see that the first reaction has that N2O5 in it, but notice it's a reactant here, not a product like I want in the overall. So what am I going to do? I'm going to flip this. Okay, I'm going to flip the entire step. So instead of having N2O5 as a reactant, now we're going to have 2 moles of NO as a reactant plus 3/4 moles O2 forming 1 mole of N2O5. Right? So now in my overall I got the product that I want. I just had to flip this step. So to my delta H, because I flipped the reaction, I have to change the sign of the delta H of that step. So instead of having positive 223.7 kilojoules, and I'm going to do negative 223.7 kilojoules. Okay? So whenever you flip, you change the sign. If this would have been negative, I would have made this positive. So I got 1 mole of that. I do want some O2, but I don't want 3/4 moles. I want a half. So I'm knowing right now I'm going to have to cancel out some O2. So the next step is going to probably have some O2 in the product, so I can do that. But let's take a look at it. I want NO2 as a reactant in the overall, but right here in this step, I got NO2 as a product. So I know I'm going to flip this one too. So I'm going to do initially exactly what it says, just flipping the reactants and the products. Okay? So I did that flip right there, but careful to recognize that I want 2 moles of NO2 in the product, not just 1. So I'm also going to double everything. So 2 moles of NO2, that means I'm going to have 2 moles of NO. 2 of a half, right? 2 times a half gives me 1. So all of this now just reduces to 1 mole of O2. Okay? So I'm going to rewrite that just a little bit cleaner down below here. So 2 NO2, 2 NO, plus 1 mole of O2. Okay? And I'll put a little notes here. I flipped this one, I flipped this one, and then I also multiplied the coefficients by 2. The notes just help me keep track and make sure I did what I was supposed to do to the delta H for each part. Alright, so let's do delta H2 now. Alright, I flipped it so it's going to be positive 57.1 kilojoules, but I also doubled the coefficient, so I got to multiply this by 2, right? That's going to give me 114, what is that, 114.2 kilojoules. Okay? Alright, so let's now look at see if we have everything we want in our overall, and see if we cancel everything, or we'll have to change something, right? So I want 2 moles of NO as a reactant. I got it right there. It's not canceling with anything in the first step, so I'm good. Alright, half a mole of O2. I have 1 mole in the product and 3/4, or this is the same thing as thinking of it as 1.5, right? Whenever you have things on that match, molecules that is, on the reactant side of one step and the product side, you can cancel them out. But I don't have equal amounts here. I have 1 mole in the product in this step of O2, and then I have 1.5 here. So when you cancel 1 mole away from 1.5, what are you left with? You're left with half a mole of O2 and your reactant, which is exactly what I want. So then O2 is all good. And then finally, my 2 moles of NO, That's not even in the overall, so I could cancel that. They're on the opposite sides. Here's the reactant in this step. It's a product in this step. And then I want 1 mole of N2O5. I'm good. So I did everything I needed to. Now I just have to figure out the delta H of the overall. So that's going to be the delta H1 plus the delta H2 for my steps. And I've already flipped them, changed the signs, and multiplied this one by 2. So it's just adding together now those steps. Negative 223.7 kilojoules plus 114.2 kilojoules. And my answer, let's break out the calculator, gives me negative 109.5 kilojoules. So that's how these problems work, guys. You got to rearrange the steps, flip them. You can multiply coefficients by 2. Don't be tricked by canceling out moles. If they don't match exactly, you just figure out how many moles are left. It's basically subtraction, right? 1.5 minus 1 left me with half as a reactant. Okay. I know it takes some practice, a little tricky at first, but hopefully this helps.